Now, students, today's topic for discussion is electric field. And now, in our previous lessons, we have been talking about electrostatics. Now, we are approaching slowly and slowly towards the current electricity. That is our main topic in this grade 10th class. This chapter number 8 is basically based on the majority of electricity, but some part was there related to the electrostatic. So before going to the electric current and electric circuits, let's discuss about what do you mean by electric field. So in electric field topic, children, just focus on this screen here, children, on this diagram. In this diagram, you find that this is our Earth. This is our planet, a blue planet. And about this blue planet, suppose in the atmosphere of Earth, there is an object. And what will happen with this object? You can see this object is start moving towards the center of the earth. Means any object, if I throw any object upward, then finally it come back to the earth. So why this object return back to the surface of earth? The reason is that due to the force of gravity, that gravitation field is there. Already this concept we are aware in grade 9. So basically that as we are talking about the field, especially the electric field, now as we have a planet Earth, so around the Earth, there is certain field that is called the gravitational field. Due to the presence of that field, Earth is able to attract some objects, or means every object, towards its center. Let me move to the next point. Similarly, we have a case of magnet. In the case of magnet, you know, that you can see on the screen, we have two bar magnets having two poles, north, south, north, south. In case of the magnet, you know that when you bring opposite poles towards each other or the same pole towards each other, so then at that time they also start attracting or repelling. As you can see in this diagram also, that the pole, this magnet, they starts moving towards each other. Why they moves? Why they move towards each other? So it means about the each magnet or about around each pole, there is certain field, and the name given to that field is called the magnetic field. Basically, children, that this magnetic field concept we are going to discuss in our chapter number 9. That is our chapter number 9, magnetic field. But here, just talking about the field, so about around the magnet, there is a certain field that is called a magnetic field. Now, to discuss about that, what is electric field here, children, that again I want to go to this field is the space property. It is a space property, means whether it is a earth, whether it is a gravitational field, or whether it is a magnetic field. Actually, it is the space around a body. It is the space around a body. So let us define this electric field before going to the definition of electric field. Again, just focus on one of this diagram. Observe carefully, children, that the two charges, they repel each other. And if I bring two oppositely charged particles, then you find they will attract towards each other. Why they are repelling, why they are attracting? As we know that there is a field, because each particle, each charged body or each charged particle is in the field of the another charged particle. So then due to the field around the charged particle, they will experience a force, and that's why we have the Coulomb's law that the charge may attract and charge may repel each other. Now here, children, whenever you find a single isolated positively charged or a negatively charged body, single isolated positively charged or negative charged body, so around that charged body there is a space. Around that charged body, children, listen carefully, there will be some space. And what is the name given to that space? That is called the electric field. The space around a charged body, whether body is positively charged, whether it is a negatively charged body, that space is called the electric field. Means around the positive charge, around the negative charge body, there is a space that is called the electric field. But what is the proper definition of electric field? Let's see. The space around the charge body in which the influence of charge can be felt. The space around the charge body in which the influence of charge can be felt means that we can experience a repulsive force or attractive force. That field is called, that electric field. So let me explain in other words, children, that it is the space around a charged body, and if in that field, if I bring any other charged body, so that charged body will experience a force. So depending upon the nature of the charges, if both the charged bodies are of the same polarity, of same nature, then the force will be repulsive, and otherwise force will be attractive if the charges are of opposite natures. So this is something about the electric field, children. Basically, it is a space property which is related to the space around a charged body. Charged body means, again, it can be positively charged body, it can be a negatively charged body. Let me move to the next slide. Now, next point is, children, electric field intensity. I want to explain this topic to all of you and listen it carefully. Even though you can't find this topic in your textbook, but this is also an important topic for this particular chapter. What do you mean by electric field intensity? Actually, basically, electric field intensity is the measure of strength of an electric field. Strength of electric field. Suppose in this diagram, children, you can see we have a positively charged body. 10th class students, please keep your camera on. Now here in this diagram, we have a positively charged body, and listen carefully, pay attention. So around this charged body, near to the charged body or away from the charged body, definitely the field will be stronger or weak. So electric field intensity confirms. It confirms, as see the definition here on the screen, electric field intensity is the measure of the strength of an electric field. Suppose, children, if I take 2 points, one point A and another point B here near to the arrow. Now the question is, at what point, means whether at point A the strength of electric field is higher or at point B the strength of electric field is higher. So to understand or to calculate or to measure the strength or in other words the power of electric field, whether the field is strong or weak, that explanation is given by the concept of electric field intensity. What is the mathematical equation of electric field intensity, children? You can find that the mathematical equation for electric field intensity is force divided by charge. It is given by force divided by charge. Means force acting per unit charge, that is called electric field intensity. Means how much force is acting on a charged body. For example, again, children, just focus on this diagram. We have positively charged body, this plus Q charge. Let me write here plus Q charge. Plus Q charge is there. And another charge, this is Q naught. So definitely according to the Coulomb's law, there will be a force. There will be a force. But how to calculate how much is the force? But basically we need to calculate what is the amount of electric field intensity. So electric field intensity is given by how much force is acting, on this unit charge Q naught. So that gives you the magnitude or the value of electric field intensity. Now students, from the Coulomb's law, this F can be further written as F is equal to K. I have taken the plus charge, that is a Q. Second charge body, this is Q naught, divided by the distance of square of the distance between them. Suppose there is a certain distance between Q and Q naught, that is R square, and divided by here this term Q naught. So then Q naught will be cancelled by Q naught, and finally I can write this result: electric field intensity is inversely proportional to square of the distance. This is a very, very important result, children. Electric field intensity is inversely proportional to the square of the distance. What do you mean by this part here? As you increase the distance from the means as you move away from the positively charged body or negatively charged body, strength of electric field intensity decreases. That is the meaning. That is the meaning of this topic of electric field intensity. Electric field intensity at any point in electric field is the force acting on a unit positive charge placed at that point. Force divided by charge, that is the equation for electric field intensity, and it is inversely proportional to the square of the distance. I hope that, let me take another example, children. This is our positively charged body. About this positive charge, there is a field, there is a space that is called the electric field. If I take 2 points again, the point number A and another point number B. So at what point electric field is stronger? At point A or at point B? Any student? At what point that the electric field is stronger? You tell me. EA is greater than EB or EB?
Sir,
EA is less than EB.
EA is greater. EA is greater than EB.
Yes, how you can say that the electric field intensity at A will be larger? You can understand, you can remember this equation, that as A is inversely proportional to the square of the distance, lesser the distance. So in case of when we are considering the point A, at this point, due to this plus Q charge, then the electric field will be the distance is less, electric field will be larger. Strong electric field will be there near to a charged body, and as we move away from the charged body, and this happens actually, this happens in real practice also. If you take a bar magnet, let me take an example. If you take a bar magnet, students, what happens in the bar magnet? If you take a magnetic materials near to the bar magnet, that the magnetic material will be attracted by the bar magnet. But if you take that magnetic material away from the magnet, then you know that it will be difficult for the bar magnet. Now, our next topic, students, type of electric field, and this is also a very important topic. And in types of electric field, students, basically we have many different type of electric field, and here on the screen you can find uh, uniform electric field, non-uniform electric field, radial electric field. Now, the next few minutes I am going to spend on these three topics: uniform, non-uniform, and radial electric field. And listen carefully. What do you mean by uniform electric field? Now, see this diagram. Whenever, children, you find the electric field lines in a parallel, completely parallel to each other, whether these are in a horizontal plane or in a vertical plane, in any way, if the lines are parallel, parallel means they are equal spacing. Basically, it should be equal spacing. Equal spacing. Spacing should be equal among all these lines, whether 2 lines are there, 4 lines are there, 5 lines are there, means electric field line should be equal spacing and parallel to each other. That field is called uniform electric field. In a definition point of view, when magnitude as well as direction of electric field intensity is same at all points in the electric field. For example, student, just observe this diagram. And in this diagram, if I place one charge QA and another charge somewhere at this point QB, I have placed the two charge bodies, the two charges QA and QB. Remember that QA and QB, their magnitude is same. QA is equal to QB. And now the question is there, will the forces acting on the charge Q and QB will be same or different? The force acting on the charge QA and the force acting on the charge B will be same or different. Remember, this is uniform electric field. Any student from grade 10, sit down. Any idea? Will the force will be same? How will you calculate the force? You know the expression for the electric field intensity, E is equal to F by Q naught. So now this charge is QA or QB, and F will be Q naught multiplied by electric field. Now, any student, Meher, force
Yes,
will
sir.
be same or different? That is the question.
Uh, Maybe same.
Will be same. Astha said your voice is lagging me. Okay, Astha, let me repeat. The question is the two charged particles of the same magnitude, QA is equal to QB, they are placed in the uniform electric field, and the question is whether the force acting on these two charged particles, which are at the different positions but are in the same electric field, will this force will be same or different? So whether this force will be different or same, let me explain. As you know, the expression F is equal to Q naught multiplied by E. We have told that the field is uniform. Uniform means that the electric field intensity E is constant. This E is constant. This E is constant, children. And Q naught is same. So it means whatever the value of the Q naught, whatever the value of E, so it means we are going to get a constant force. F will be constant.
Yes.
Be constant means that the same force will act on the charge particle A and the charge particle B, because we have taken that the same charges are there. So in electric field, if it is uniform, then what happens? At each and every point in the electric field, first point that the electric field intensity will remain the same. That is the main thing. Now the next point. This is about the uniform electric field. Let's talk about the non-uniform electric field. Non-uniform electric field, see the diagrams. Lines are not exactly parallel. These are slightly in the form of curve. And even you can also represent the non-uniform electric field. For example, need to annotate. One line, second line, third, fourth, and this. This entire region of space, this is the electric field, they are going from left to right. Suppose let me put the arrow signs, going from left to right. Even though the lines are parallel, so parallel lines is not the necessary condition for the uniform fields. Means first condition is that line should be parallel, but it should be equal spacing. But in this entire region of space, somewhere the lines are spacing is less, somewhere the spacing is large. So this entire region of space is not a uniform electric field. That region of space is called the non-uniform electric field. Non-uniform electric field means somewhere the electric field will be strong, somewhere electric field will be weak. Is this clear, children? This point, what do you mean by the non-electric field, non-uniform electric field, Anirudh?
Yes, sir.
Similarly, for this diagram here in this PPT, that the curved line, that the electric field is different at each and every point. Basically, that this idea of non-uniform electric field will you get from this diagram very clearly. Now, students, one more point I want to add here with this topic. Whenever you find the lines are very closer to each other, or the region of space where the lines are very closer, that region of space is also called the strong electric field is there. Now let me mark in this region the region A and region B. Let me take another color also. This is our space B or region B, and this is region A. In both this region A and B, and this question is for Harshan, can you tell me which space A or B the strength of electric field is large? In the region of space A or in the region of space B?
Sir, is it A?
You said A. What about Jordan?
think A also, sir.
Yeah, you said the A. Anirudh?
Yes,
Yeah, this is A. And why it is A, as I told you earlier, children, that the region of space where the lines are crowded, lines are closer to each other, that represent the strong electric field. Even in terms of magnetic field, when we will come to the magnetic field chapter, so in terms of magnet, the magnetic field will also be stronger in that particular region of space. So this is something about the non-uniform. Let's move to the third category of the electric field, and that is the radial electric field. Radial electric field. Radial electric field means this diagram is corresponding to the positive charge. They have not mentioned the positive charge, but let me put here. This is a positively charged body. If we have a positively charged body, the direction of electric field line, these will be outward, radially outward. It's a mathematical terms, radially, radial electric field towards the away from the center in case of positive charged body, radial outward. It's like a radial outward. And in case of negative, suppose let be negative charge diagram is not shown in this diagram in this PPT. If the charge is negative, let me just take few electric field lines. In case of this electric field due to negative, so the direction of the electric field lines, it will be towards the negatively charged body. Please remember. So radial electric field means the field is directed towards or away from the same fixed point. Towards means if it is a negatively charged body. Away means if it is a positively charged body. Please remember the direction of electric fields.
yes, sir.
Even in, please, if you can open your textbook, students, in your textbook on page number 174, that the book which I have, 174 and topic number 8.03. In the bottom of that, on the page, you will find that a negatively charged body is shown. And in the negatively charged body, you can see that the direction of arrows, that the electric field lines are going towards the negatively charged body. Let me move to the next slide, students. And now, students, here in this diagram, you can find we have a positively charged body. This is a positive charge. And we know that due to the positive charge body, that the direction of electric field lines, these are outwards. And these outwards are radial outwards. It is radially outwards, whether it is positive or negative charge. And now the question is, if I place another charge body, suppose let me take this Q naught charge. I have placed this Q naught charge, means another charge body, in the electric field generated or produced by this plus Q. This is plus Q. Now, children, whenever you find that if we have a positively charged body, and in this positively charged body, we have placed another positive charged body, then we know as per the Coulomb's law, this Q naught will experience a force as this is a free charge. This plus Q is fixed. Plus Q is fixed, it won't move, but Q naught is free. So the plus Q charge will able to make this Q naught charge, means it will, plus Q charge will apply a repulsive force on Q naught. And due to that repulsive force, there will be a repulsive force between Q and Q naught, I will say. And Q naught may move away from the Q. So remember, students, that the movement of this Q naught charge, the movement of the plus Q charge, plus Q naught charge, this will always in the direction of electric field. In your exams, in IGCSE exam, what type of questions you may find? Questions will be like that. If we have a positive charge body and another positive charge body is placed, so in what directions will that another positive charge body will move? Then your answer will be this q naught charge will move in the direction of electric field intensity. So it means the direction of the force will be outward, and the direction of the force is the same as the direction of electric field intensity. So remember, student, please note down somewhere, if you place a q naught charge in the field produced by a positive charge body, so that q naught charge will move in the direction of electric field. Remember, let me draw this diagram one more time. We have this diagram, and this is q naught charge. Now the question is that in what direction this q naught will go? It will go outward or it will move inward? That is the question actually. So in simple words, that this q naught charge particle will go in the direction of electric field. And I know that due to the positive charge particle, electric fields are outward. These are outward. These are outward. In any way you can draw how many lines you want to draw, you can draw. So it means this q naught will also go along this direction of the electric field. But the same charge particle is placed here, q naught. The same charge particle is placed here. So may I ask this question to Pari? Yeah, just wait a minute. Let me ask this question to Pari. Pari, can you explain what will be the direction of this q naught? This will move towards the negative or away from the negative?
Towards the negative.
Yeah, towards the negative. From this diagram, it is also very clear, as I told you, the concept that whether we have a positive charge particles, whether this positive charge particle is placed in a positive electric field or or the electric field produced by the negative charge, always this positive charge particle move in the direction of electric field. In the case of electric field produced by the negative charge, electric field lines are going radially inwards. These are inwards. You can see here from the diagram. So that's why this charge particles will also go inward. But students get confused in a situation if I ask you, instead of taking the positive charge, if I take the minus charge. Suppose this is minus q naught. If the charge is minus q naught, children, then what will happen?
It will go towards.
Sir, it will go towards.
Towards what?
Towards the positive charge.
Towards the positive charge.
Towards
Yes.
the
Now in
positive
that case,
charge.
yeah, in that case, that the concept slightly changed. Now you will say if the charge is negative, then the negative charge will move opposite to the direction of electric field, children. Opposite to the direction of electric field. Here the electric field is outward, but this movement in this minus q naught will be opposite to the electric field direction. This minus q naught will be attracted by the positive charge. Similarly, if I placed the same minus q naught charge in the negative field, means field produced by a negative charge, then again the concept, if we have a negative charge body placed in a charged field, so this minus q naught will move in what direction? Opposite to the direction of electric field. Here the electric field is inward, but this minus q naught will go opposite to the direction of electric field, children. Opposite to the direction of electric field. Please remember all these points. Now less than 1 minute left for this meeting. Let me pause this recording.